Welcome to lesson P6. Um, we're going to discuss all kinds of functions and the different forms of linear functions. So our objective is we're going to calculate slope first, then write equations of lines, graph them in slope-intercept standard and point slope form. So a lot of what you talked about in Algebra 1 over the course of a long period of time, we're going to cover all at once here as a review. First definition, a linear function is a function whose graph is a line. All right. Right here, we're going to look at three different forms of the exact same thing. So whether you write an equation, whether you have a table, whether you have a graph, this all represents the same function. Let me also throw in here writing it in function notation that we talked about before, also means the same thing. A couple definitions that we'll talk about here. Independent variable. So typically that's the x value and always the horizontal axis on a graph. The dependent variable depends on the independent variable. An example of an independent variable is time. Anytime time is one of your variables, it's going to be your x value or your independent variable. Okay. So pause there if you need to write it down. Dependent variables are typically the y value and always the vertical axis. An example of that could be distance in a situation where you're deciding between, which piece of information is the independent, which is the dependent. But generally speaking, independent is your x, dependent is your y. A couple more definitions. Y-intercept. It's the exact point where a graph crosses the y-axis. So in this case, it's right here on this graph. The x-intercept is the exact point where a graph crosses the x-axis. So for this one, it's here. Slope is considered the ratio of the vertical change to the corresponding horizontal change. You've also heard this described as rise over run. And here's the formula for slope. So y2 minus y1 over x2 minus x1, where x1, y1 are the coordinates of one ordered pair and x2 and y2 are the coordinates of another ordered pair. All right, so let's see exactly which ones we're going to be. All right, so between A and B is the first one. So if we're going to figure out what is the slope between points A and B, we're going to take those ordered pairs. So from A to B, what is the slope? That was the first one we had to do. So if my ordered pairs are -5, 5, that's my x1 and my y1. The other ordered pair is 2, 2, so that's my x2 and my y2. Now it does not matter which point you make the 1 and which point you make the 2 as long as the ordered pair stays together. Like you can't mix and match. Now if I use the formula, y2 minus y1 would be 2 minus 5. And then x2 minus x1 would be 2 minus -5, so 2 plus 5. So you end up with -3 over 7. All right, so -3/7. I believe the next one is from B to C. So like what is the slope between those two ordered pairs? So again, I have my ordered pairs 2, 2, and 2, -5. This is my x1, this is my y1, this is my x2, this is my y2. y2 minus y1 will be -5 minus 2. x2 minus x1 will be 2 minus 2. So it'll be negative 7 over 0. If you get 0 as a denominator, you can never divide by 0. So this would be considered an undefined slope. Another way you might hear this described is simply no slope. All right, I believe the next one is then C to D. Scroll down and get a little more room. We'll do it down here. So C to D, ordered pair of 2, negative 5, and then negative 6, negative 5. So x1, y1, x2, y2. So it'll be negative 5 minus negative 5, so plus 5. All that divided by negative 6 minus 2. So you get 0 over negative 8. 0 divided by anything is equal to 0. This is not undefined. This is not no slope. This is a slope of 0. Okay, so we'll talk about this later. But again, I want to reiterate, a vertical line, like we had from B to C, a vertical line has no slope. A horizontal line, like it is between C and D, has a slope of 0. That is different. So 0 is not undefined, and undefined is not 0. I know there's a couple others. I'll let you try them on your own. Now let's talk about slope-intercept form. So slope-intercept form is y equals mx plus b, where m is the slope that we just talked about, and b is the y-intercept that we defined a couple slides ago. All right. So if you're given an equation in slope-intercept form, you have enough information to graph. The first thing you're going to do is plot the point on the y-intercept. The y-intercept is at negative 2. All right. Given that the y-intercept's at negative 2, a mistake I see all the time is people trying to plot it on the x-axis. It's always going to be on the y-axis. You have slope-intercept form, you start with the y-intercept at negative 2, and then you're going to apply the slope from that point. You just need to get one more. Rise over run means you go up 3 and then right 4. So you go 1, 2, 3, right 1, 2, 3, 4. You can apply it more than once so you can draw a line better, but one is enough. You can draw your line through those 2 points. I want to plot a couple more just to be, make it a little neater. Again, from that point now I can apply the rise, which is 1, 2, 3, and then the run, which is 1, 2, 3, 4. Let's say you're in a situation where you wanted another point. Well, if I go up 3 and right 4, I'm off the graph, right? So I can't really plot that point. If I go back to my y-intercept, I can go the other direction because 3/4 is equal to negative 3 over negative 4, right? So I can manipulate the negative signs to make it do the opposite, right? So a rise of negative 3 would be down 3, 1, 2, 3. And a run of negative 4 would be left instead of right. So 1, 2, 3, 4. Notice how by applying the slope as both opposite, I can still end up on the same line. Right, now I'm going to try to, I don't really know if I can use a straight edge here. That's not bad. If you're doing this by hand, I would recommend using a straight edge. I don't really have a straight edge I can use on my tablet here. All right, let's move on to the next one. Same thing. I'm going to apply the y-intercept first of 1. So that's here. A slope of negative 6. So when it's an integer, treat it like it's over 1. The rise is the numerator. The run is the denominator, which is 1. So a rise of negative 6 means I go down 1, 2, 3, 4, 5, 6, and then right 1. Okay, I can draw my line through that. Let's say I want it to go the other direction. I can do the opposite thing that I was talking about in the last one. The opposite of 6 is negative 6 is positive 6. The opposite of 1 is negative 1. As long as I make them both opposites, I can apply the slope then. A rise of 6 is up 1, 2, 3, 4, 5, 6, and then a run of negative 1 is left instead of right. Again, notice how these line up. All right. Y equals 3. This is a situation where every ordered pair on the graph uh, has a y coordinate of 3. It also has a y-intercept of 3. Right? At this point, again, if I just plot points, like just pick some points, the x can be anything you want, and the y value is going to be 3. When it says y equals 3, that y is going to be 3 every time. So 1, 3 would be there, 2, 3 would be there. It's a horizontal. You don't need to plot all those extra points. I was just showing you why. Y equals a number will always be horizontal. And the y-intercept will be that number. All right. I'm going to skip over to this one that's x equals a number, and we'll go back to part D in a second. But x equals a number means every x coordinate is negative 2. It has an x-intercept of negative 2. So if I were to plot some other points, the x value is negative 2, maybe I have a y value of 4. So negative 2, 4 would be here. If I have an x value of negative 2, I could also have a y value of negative 3. Point is, it doesn't matter what I pick for y because the x is always going to be negative 2. It's a vertical line through negative 2 with an x-intercept of negative 2. X equals a number will always be vertical. Okay? Something like part D here, y equals negative 4x, there is no y-intercept. There is no number there. So I misspoke. It's not that there's no y-intercept. There's no b in the equation. But it doesn't mean the y-intercept doesn't exist. It means the y-intercept is 0. You're just not writing plus 0. You would never write that, but that's what that means. Okay? Then the slope of negative 4, when we talk about how treat that like it's over 1, the rise is negative 4, so that means I'm going down 1, 2, 3, 4, and then right 1. Down 1, 2, 3, 4, and then right 1. And then you'll draw your line through that. So equations like the one in part D, where there is no number and the y-intercept is 0, will go through the origin. Okay? We just did that one. Let's talk about standard form. So standard form of a linear equation is ax plus by equals c, where a, b, and c are integers. They're not going to be fractions or decimals. And then the a should be positive. You can't guarantee the b and the c are positive if the a is positive because they might be opposites. We're going to graph each a line in standard form by finding the intercepts. The way we're going to do that is the x-intercept. Well, what do I know about the x-intercept? The x-intercept is where it crosses the x-axis. The y value of any x-intercept is 0. So essentially what's going to happen is if I substitute 0 in for y, I'm left with just the 3x equals 12. So you can ignore the y when you're finding the x-intercept. It's called cover-up method. Now you just divide by 3. You get x equals 4, which means the x-intercept is 4, 0. So we can plot that point. Y-intercept is just the same. The y-intercept is when it's on the y-axis. What I can guarantee about any point on the y-axis is the x value is 0. So if I substitute 0 in for x, 3 times 0 is 0, and I'm gone. So really, is to find the y-intercept, I'm just going to look at, that's horrible. That's better. the equation without the x, so 6y equals 12. I'm going to divide both sides by 6, and then I get y equals 2. And the ordered pair is 0, 2. That point will be right here. Having both intercepts is enough to draw a line. I can draw my line through those intercepts, and that's good enough. Same thing is going to happen here. That's in standard form. If I'm graphing from standard form, I can just find the intercepts. So for the x-intercept, I can just say 2x is equal to 4. Just getting rid of the y, because the x-intercept is where y is 0. Divide both sides by 2, I get x equals 2. So that means my x-intercept is at 2. Negative 8y equals 4. Divide both sides by negative 8, and I get y equals negative 1/2. Negative 1/2 would be in there, and then I can draw my line through that. Last form that we're going to talk about is point-slope form. So point-slope form is y minus y1 is equal to m times x minus x1, where x1, y1 is a point, and the m is the same m we've been talking about, which is the slope. All right, so if I want to write an equation in point-slope form that has this point and this slope, I can use point-slope form. If I want to write it in standard form, I want to use point-slope form to get there. All right, so let's first get it in point-slope form. So again, this is x1, this is y1, and then this is your m. Just substitute it into the form. So y minus y1, rewrite the form down here so you can see it better. y1 is negative 1, so y minus negative 1 is going to end up being y plus 1. The m is given as 1/2, and then in parentheses it's x minus x1, which is 8. Okay, so this is the equation of the line in point-slope form. If I wanted to get it in standard form, well, remember what standard form looks like. It's ax plus by equals c. So I have to essentially break it all apart. So I'm going to get y plus 1, and then distribute the 1/2. You get 1/2 times x, and then 1/2 times negative 4 is negative 4. Remember, the x came first, so I'm going to subtract that to the other side. Then I get negative 1/2 x plus y plus 1 equals negative 4. Remember, there's no constant on the left side, so I'm going to subtract that 1 to the other side, and I get negative 1/2 x plus y is equal to negative 5. And then remember the rule about the coefficients of x, y, and then the constant, the a, b, and c have to be integers. Well, that's a fraction. Easy way to fix that from being a fraction is I multiply that by 2. Actually, we want the a to be positive, so we'll multiply by negative 2. If I multiply that by negative 2, I just need to multiply the coefficient of the other terms by negative 2 as well. So essentially, I'm just going to multiply the entire equation, both sides, by negative 2. Negative 2 times negative 1/2 is 1. So now I just have x. Negative 2 times y is negative 2y. Negative 2 times negative 5 is 10. Okay. I can go ahead and graph the equation from standard form. The other thing I can do, listen, you had enough information from the beginning to graph. I can just plot that point of 8, negative 1. So write 1, 2, 3, 4, 6, 7, 8, and then negative 1 is down here. Then the slope of 1/2 means I go up 1 and right 2. It also means I can do the opposite like we've been talking about, so I can go down 1 and left 2 as well. down 1 and left 2. And then I can just draw my line through that. So the reality is, if you have a point and a slope, that's enough information to graph. You don't have to convert it to anything. But, I mean, the question asks us to convert it to standard form, which is x minus 2y equals 10. And again, the y plus 1 equals 1/2 times x minus 8. That was the equation in point slope form. I'm going to leave this. We'll do a separate lesson starting next week. So the idea of getting 2 points and trying to get an equation. And then we'll also talk about next week parallel lines and perpendicular lines. So for right now, you're going to end up doing, again, notes I'm going to have due by Monday. And then on Monday, we're going to have time to start a practice. That's going to involve practicing finding slope and then practicing point slope form, slope intercept form, and standard form. Okay. Let me know if you have any questions. But again, try to get these notes completed by Monday. Have a good weekend.